Hello everyone and welcome to my channel Network Bytes with Laksh. In today's video, we will look at LSA type 4 and type 5, who generates it and how they are generated. But before we jump on to that discussion, let's just have a recap of what we saw in the last video. So in the last video, we saw about OSPF areas and LSA type 3. We discussed what are the problems that will be generated or what may be seen when we have a single OSPF area network. So we will have a lot of LSA flooding in the network, even if one single network goes down or a single router goes down. And the convergence of the cost calculation or the alternate path will happen from end to end of the OSPF network. Then we saw that because of a single OSPF area network, and if any one of the link goes down, all the routers they need to update their database. With that, number of LSA flooding, and every single time there is a database change, the CPU processing increases. So for that, we brought in different OSPF areas. So dividing a bigger OSPF area or a single OSPF area or a network into smaller OSPF areas is what area is all about. So you can see that in this diagram there are three areas. And what is the advantage of having an area? Having an advantage of the area is that the LSA that is generated inside the area will be limited only to that area, which basically helps in reducing the number of LSAs, and in turn it helps in keeping the database stable of the routers. If all the LSA floodings are reduced, the database is stable. It will help in keeping the CPU processing also as low. Then we saw about what are the different type of areas we find in OSPF. We have two type of areas. One is a backbone area, the other is a non-backbone area. And in OSPF, area 0 is considered to be a backbone area. Any other area other than 0 is the non-backbone area. So in this diagram, we can see that area 0 is the backbone area, area 1 is a non-backbone area, and area 2 is a non-backbone area. Now we also saw about ABRs, area border routers. So the condition for a router to become an ABR or a area border router is that at least one of its interface should be a part of area 0, and at least one interface should be a part of non area 0. So here R3 and R4 are ABRs, wherein R4's one interface is part of area 0, R4's other interface is part of area 1. So R3 and R4 are ABRs. And we have internal routers as well. R5, R7, R9, R8, R6, R10, R1 and R2. They are internal routers, meaning that they are all, their interfaces are part of the same area. That's what internal router means. We also saw that how two routers in different area calculate their cost to reach each other. We also saw how OSPF behaves as a link state protocol inside a single area, and how OSPF behaves as a distance vector in inter-area communication. So we discussed with a practical how routers in different area calculate their cost to reach each other through the summary LSA or the type 3 LSA, wherein basically, as we saw in the last video, we took that R8 and R4, they both belong in the same area. R4 will generate a type 3 LSA and flood it in area 0, saying that if you want to reach R8, you need to go through me. So R3 here, when it receives the LSA 3, it knows that to reach R8, it needs to go to R4. And R3 will calculate its cost to reach R4. R4 has already mentioned its cost to reach R8. So in total, R3's cost to reach R8 is its cost to reach R4 plus R4's cost to reach R8. Now R3 sends this LSA in area number 2 as well. Now when R7 tries to calculate its cost to reach R8, it will calculate its cost to reach R3 plus R3's cost to reach R4 plus R4's cost to reach R8. This is how inter-area communication happens. And we also saw that when a particular router becomes an ABR, it generates a type 1 LSA as well, where it sets the B bit meaning the boundary bit, saying that I have become the area border router. Now to reach any other router in other area, send your data to me. I will help you reach the other router. This is what the B bit means. So now let's get into our today's discussion. LSA number 5 and 4. So let's discuss LSA type 5 first. Now imagine that this is an EIGRP network, meaning that EIGRP is running between R2 and R3, and OSPF is running between R1 and R2. So now R2 here becomes the ASBR, Autonomous System Boundary Router. Autonomous System Boundary Router. Just like we had an ABR in LSA number 3, similarly we have ASBR for routers which connect two different autonomous systems. Now when I'm talking about different autonomous system, I mean that it can be any other non-OSPF network. It can be EIGRP, it can be ISIS, it can be BGP, or it can be RIP, anything, right? So it should be a non-OSPF network when the ASBR creates a type 5 LSA. And how does it create? So obviously, if I want the EIGRP network, that is this 23 network, to be injected in OSPF network, I will have to redistribute it. I will have to redistribute the EIGRP network into the OSPF network. That's how I will inject it. When R2 here is the ASBR, and when it injects the EIGRP network into the OSPF network, it generates the LSA type 5 or the external LSA. It is also called as external LSA. It generates an external LSA, and it generates an external LSA and talks about the network that it is connected with. So when R2 generates a type 5 LSA or the external LSA, it will say that the network that it is connected with, that is the 23 network. Now let's check what are the contents inside the LSA file. So the content would be the network or the link that it is connected with, that is 23 network. The subnet mask of this network is 8. The subnet mask is 8. Who is the advertising router for this link? R2 is the advertising router for this link. And what is R2's cost to reach the 23 network? Now please remember that by default, whenever an ASBR injects an external network through redistribution into an OSPF network, it has a default cost of 20. It has a default cost of 20. So no matter what the interface type is, we know that R2 is connected with R3 on a fast Ethernet link, and in OSPF the fast Ethernet link has a cost of 1. But since it's an EIGRP network, R2 will consider its cost as 20 when it injects it into the OSPF network. So R2's cost to reach 23 network is 20. And what is the route type? Is it an E1 route or is it an E2 route? We will talk about E1 route and E2 route in some time. Okay, so these are the contents inside the LSA type 5. Now let's take another example here. Between R3 and R4, EIGRP is running, and between R1, R2, and R3, OSPF is running. So here, R3 is the ASBR, right? So let's understand how R1 will calculate its cost to reach the EIGRP network. So when R3 injects the EIGRP network into the OSPF network via redistribution, it will generate a type 5 LSA, and it will send that type 5 LSA to R2 and R1, saying that its cost to reach the EIGRP network is 20. Now when R1 receives this LSA type 5, R1 knows to reach EIGRP network, R3's cost is 20. Now R1 will calculate its own cost to reach R3. And since R1 is connected to R3 via a fast Ethernet link, so the cost is 1. So R1's total cost to reach the EIGRP network is going to be 1 plus 20 equals 21. This is how a router in other area calculate its cost to reach the external network, that is 21. Again, please remember, we will talk about E1 and E2 route in some time. When we are talking about E1 and E2 route, we will understand that this calculation is a bit different, but this is just for understanding's sake, that how R1 will calculate its cost to reach the EIGRP network. Now let's take another example here. Between R2 and R6, EIGRP is running, and between R2 and beyond is what OSPF is running. You have two areas, area 0 and area 1. So R2 here is the ASBR, autonomous system boundary router, and R1 is the ABR, since R1 is connected to both the areas, area 1 and area 0. So now when R2 injects the EIGRP route into area 1 via redistribution, it will send LSA number 5. Now please remember that LSA 5 does not belong to a particular area. Again, LSA number 5 does not belong to an area. The reason is that in LSA number 5, the network that R2 is talking about, R2 is talking about the EIGRP network. The EIGRP network does not belong in an area. It belongs to the EIGRP network, and hence LSA 5 also does not belong to an area, and hence the LSA number 5 will be passed on or forwarded to the routers in area 0 as well. So R1, R3, R4 and R5, they all know to reach the EIGRP network, they will have to go to the ASBR R2. So we had discussed when R2 sends the LSA 5, the information will be about the EIGRP network. Then the subnet mask of this EIGRP network, who is the advertising router? R2 is the advertising router, and R2's cost to reach the EIGRP network by default, which is 20. And is it an E1 route or E2 route? Again, we will discuss E1 and E2 in some time. Okay, so this information is shared across all the areas in the OSPF network. So here R1 and R3 are directly connected to R2. They know who the ASBR is. How? We know that in when R1 becomes the ABR, R1 will generate a B bit, correct? R1 will generate a B bit telling that it has become the ABR. Similarly, when R2 becomes the ASBR, it will send out, let me change the color, it will send out a type 1 LSA. It will send out a type 1 LSA where it will have the E bit set, saying that I am the external boundary router, meaning that I have become the ASBR. And we know that type 1 LSA can never cross its own area. So obviously this type 1 LSA is never ever be sent out to area 0 through R1, correct? Now what is happening here is that R1 will forward LSA number 5, but in the LSA 5, to reach the external network, the router is R2. So R4 and R5, they know to reach the external network, they need to reach R2, but they do not know how to reach R2, right? Because there is no such information about it, how to reach R2 through to go to the external network, right? Now, when R1 forwards this LSA number 5, it also forwards something called as LSA number 4, type 4 LSA. Type 4 LSA, meaning that in the type 4 LSA, R1 will say that to R2 is the ASBR, and to reach R2, you need to reach out to me. I will forward your data to R2. So in this way, when R1 generates a type 4 LSA, R4 and R5 know how to reach the ASBR, and that is through R1, and that is through R1. So your ASBR generates a type 5 LSA, and the ABR generates a type 4 LSA. ABR also generates a type 3 LSA, which we had discussed in the last video. So ABR will only generate type 3 and type 4 both. ASBR never generates a type 4. It always generates a type 5 LSA. So now when R5 wants to calculate its cost to reach EIGRP, it knows through the type 4 that to reach the ASBR, it needs to reach its own ABR first. So R5 is going to calculate its cost to reach the ABR. And in this scenario, that is 1 because it's a fast Ethernet link. Then R1 knows how to reach the ASBR because they both are part of the same area. So R1's cost to reach the ASBR is again 1. And now R2 is telling its cost to reach the EIGRP is 20. So in total, the cost is 22 for R5 to reach the external network. Similarly, for R4 as well, the cost is going to be 22 to reach the EIGRP network. So this is how a type 4 LSA and a type 5 LSA are generated. Let's look at another scenario here. Now R4 is the ASBR. That means R4 is connected to an external network. It can be anything. It can be EIGRP, it can be EIGRP, ISIS, or a BGP network. It can also be another OSPF process as well. Here, if I'm running OSPF process 1, and here, if I'm running OSPF process 2. So, if I want OSPF process 2 information to be injected into OSPF process 1, I will have to redistribute. That is again a redistribution. That is again external network. Let's not diverge into that discussion for now. Let's just imagine we have EIGRP or BGP or an ISIS network connected to R4. So R4 will generate a type 5 LSA and will forward it to R2 and R3. R3 will forward that type 5 LSA to R1, right? Along with this type 5 LSA, they will also send their type 4 LSA, right? So now R1 has two ways to reach R4. One is via R2 and one is via R3. Which one will it choose, right? It will again choose based on the least cost. We know that on a serial interface, the cost is 64, and on the fast Ethernet link, the cost is 1. So this is also 1 and this is also 1. So R1's cost to reach the external network via R2 is going to be 1 plus 64 plus 20. 1 plus 64 plus 20 because that's 20 is the default cost, right? So 65 plus 20, we have 85. 85 as its total cost. And R1's total cost to reach the external network via R3 is going to be 1 plus 1 plus 1 plus 20 gives us 22. So obviously R1 is going to choose its path to reach ASBR through R3 rather than R2. So this is how R1 will calculate its best path. Now let's take another example. R1 is the ASBR. And this is area 1 and this is area 0. Right. R1 here will generate a type 5 LSA, LSA number 5 in area number 1 as well as in area number 0 as well. Here there will be no need for a type 4 LSA to be created. R1 is acting as an ASBR as well as an ABR because R1 is connected to an external network here as well as it is connected to area 0 and area 1. So R1 is acting as ASBR as well as ABR both. And here R1, though it's an ABR, it's not going to generate a type 4 LSA because it's directly connected to both the devices in those areas. So there is no need for a type 4 LSA. When will there be a type 4 LSA needed? If R3 here is connected to another router and there is another area here, for example, area number 2. So R3 will generate a type 4 LSA in this part of the area so that this router knows how to reach R1 or the ASBR. Okay, so I have shown you when are the type 4 LSAs created and when are the type 5 LSAs created. So let's check this out through a practical. Here you can see that I have 4 routers created R1, R2, R3 and R4. Between R3 and R4 we have EIGRP running, and between R2, R1 and R3 there is OSPF running. R1 and R2 are part of area 0, R2 and R3 are part of area number 1. Right. So for the OSPF, EIGRP is an external network, and you can see their IP addresses and IP addresses on the interfaces. So between R1 and R2, I have 12.0.0.0/8 IP address range, meaning the IP address on R1 is 12.0.0.1, on R2 it is 12.0.0.2. Similarly, on R3 it is R2's other interface, it's 23.0.0.2. On R3 it is 23.0.0.3. On R3's other interface it is 34.0.0.3. On R4 it is 34.0.0.4. So just to simplify, on R1s, you can see that these are the interface IPs. This is the interface IP address, and I have created 3 loopback addresses. And I have created OSPF using the network command router OSPF1 network 000 255 area 0. On R2, these are the IP addresses on 0/0, 0/1, and on loopback 1 is also created with the IP address 2.2.2.2. So the loopback address and the 12 network interface are part of area 0. The other interface that is facing R3 is a part of area number 1. Similarly, on R3, these are the interface IP addresses, and a loopback is created 3.3.3.3. The network 23 that is facing R2 is part of area number 1. I have not yet created EIGRP as of now on R3. On R4 as well, we can see there is no EIGRP configured. However, you can see the IP addresses configured on R4, and I have created 3 loopback addresses. So on R3, let's create EIGRP. So configuration terminal, router EIGRP 100, network 34.0.0.0, which is the network that is facing R4. Enter. Then no auto summary. End. Now on R4 also we will enable EIGRP configuration terminal, router EIGRP 100, network 0.0.0.0, no auto summary. So we can see that the EIGRP neighborship between R3 and R4 has come up. We will see a similar syslog created on R3 as well. Now, if I do show IP protocols, we can see that we do have 2 routing protocols on R3. One is OSPF, the other is EIGRP. However, R3 has not yet become the ASBR. There is no mention of ASBR here, that it has become the ASBR. On R2, if I do a show IP protocols, you can see that it mentions it is an area border router, but there is no such line which tells that R3 is an ASBR. The reason is that I have not yet redistributed the EIGRP network into the OSPF network. Once I redistribute, R3 will become the ASBR. And how do we do the redistribution? Let's check that. Configuration terminal, router OSPF 1 redistribute EIGRP 100 subnets. Now, if we do a show IP protocols, we can see that it says it is an autonomous system boundary router and it is redistributing external routes from EIGRP 100, right? So R3 has now become the ASBR. Now, if we do a show IP OSPF database, we will see that it has a type 5 LSA created as well, which has the external networks 4.4.4.1, 4.2, 4.3, and 34 are all part of the EIGRP network, and R3 is talking about these networks through a type 5 LSA. And as I mentioned, type 5 LSA does not belong to an area. You can see here the type 1 LSA, it says area number 1. It was generated in area number 1. Netlink states, that is the network LSA or the type 2 LSA, they were generated in area number 1. Summary LSA, they were generated in area 1, that is the LSA number 3. But type 5 LSAs are external LSAs, they do not have any area. The reason is that these networks that are external to it anyway are not part of any area and any OSPF network, and hence there is no area associated to the type 5 LSA. We can see the same type 5 LSA on R1 as well. Show IP OSPF database. We can see that it is receiving a type 5 LSA and there is no area associated to it, and it knows about 4.1, 4.2, 4.3, etc. Right. Now, as I had said, when R3 becomes an ASBR, it will generate a type 1 LSA saying that it has become the ASBR. Let me show you that now. So let me open up the Wireshark and remove the redistribution first. Configuration terminal, router OSPF 1, no redistribute EIGRP 100 subnets, and as well no redistribute EIGRP 100 both. So let me just confirm. To confirm, let me do a show run. On the show run under OSPF configuration, we should not see any redistribution command. So there is no redistribution. And let's again verify with another command, show IP protocols. We will see it is not an ASBR. Right. Now let's redistribute the EIGRP network. Configuration terminal, router OSPF 1, redistribute EIGRP 100 subnets. Now we can see that R3 R3 generated an LS update, a link state update, right? So let's open that. And we can see that it has generated a type 1 LSA. It has generated a type 1 LSA, and in that type 1 LSA, what is it saying? It has a flag set, and the flag set is E bit AS boundary router, ASBR router, and it says yes, and the value is 1. So whenever a router becomes an ASBR, it it becomes an ASBR only when it redistributes the external route. The moment it redistributes, it will generate a type 5 LSA as well as a type 1 LSA saying that it has become the ASBR. Right. Now, let's go back to our diagram. So let's confirm here, show IP protocols. We can see that it has become the ASBR. show IP OSPF database. We can see that our in area number 1 we have a router LSA, that is the type 1 LSA, type 2 LSA, a type 3 LSA, and a type 5 LSA. We have three, or we have four types of LSA: type 1, type 2, type 3, and a type 5 LSA in area number 1. Let's go to R2 and do a show IP OSPF database. Let's check only for area number 1 as of now, right? And you can see that in area number 1 again we have a router LSA, network LSA, summary LSA, and a type 5 LSA. So the database matches in area number 1. The database matches in area number 1. But let's check area number 0. In area number 0 we will have an extra LSA: router LSA type 1, network LSA type 2, summary LSA type 3, summary ASBR LSA, that is the type 4 LSA, and the it generates a type 5 it has generated a type uh, 4 LSA, and this LSA is now seen here: type 4 LSA and a type 5 LSA both. So in area 0 we have 5 LSAs in total: type 1, type 2, type 3, type 4, and type 5. So let's open the type 5 LSA. To open the type 5 LSA, show IP OSPF database. To open the type 5 LSA, I have to mention external LSA because that's the name of the type 5 LSA. External LSA with the link ID 4.4.4.1. So it says that to reach 4.4.4.1, who is the advertising router? 3.3.3.3. And what is 3.3.3.3's metric or cost to reach the external network? You can see it is mentioned 20. So R3's cost to reach the external network is 20, right? And how can R1 reach R3? So show IP OSPF database, right? So to reach R3, that is this link ID, the advertising router is 2.2.2.2. It needs to go to 2.2.2.2, right? So show IP OSPF database summary ASBR, and it is 3.3.3.3. 3.3.3.3. Give me a minute. I think I'm making some mistake somewhere here. Okay, instead of that I should have mentioned 23. Twenty-three dot zero dot zero dot zero. So 23.0.0.0 is the interface, that is R3's interface, and to reach there, that is 2. So R1's cost to reach R2 is 1, right? Or we can see that show IP OSPF border routers, right? Who is the border router? 2.2.2.2 is the border router. You can see intra area route, and it says that's the ABR. So R1, if it wants to reach I is inter area route, and that's the ASBR. To reach the ASBR, that is 3.3.3.3, it should go to R2 first. And what is R1's cost to reach R2? That is 1. And what is R1's cost to reach R3? That is 2. So in total, R1's cost to reach R3 is 2. So this 2 plus R3's cost to reach the external network that we saw was 20. So in total, it should be 22. But let's check. Show IP route OSPF. We can see to reach 4.4.4.1, it's still 20, it's not 22. Now let's discuss what is E1 and E2 routes. Let's discuss what is E1 and E2 routes. Okay, and you can see that here it is mentioned as E2, and E2 means OSPF external type 2. What does that mean? It means that no matter how many areas or how many hops or how many routers does the network cross, the external E2 route cost is always going to be the same. So R3 says that its cost to reach the EIGRP network is 20, and that 20 is forwarded across the whole OSPF network. And even R1 says its cost to reach the external network is 20. That is what E2 cost means. It's ideally it should have been 22, but because the external cost, the default cost is E2, it says 22. It says 20 rather than 22. But does it really has a 20 cost? No. Inside R1, it knows the external cost is E2, and that's the default behavior. But my cost to reach the external network will obviously not be 20. It is going to be higher than 20. R1 already knows it, but in the routing table, it does not show that. And where can we see that external cost? So if I do a show IP route 4.4.4.1, we can see that it says to reach 4.4.4.1, it is known via OSPF1. The metric is 20. Type external 2, forwarding metric 2. So basically, R1 is adding the cost to reach R2 and R2's cost to reach R3. That is 2 in total, but it is not showing in the routing table. The reason is that because the default metric is E2, type external 2. So 20 plus 2, 22 is R1's actual cost. But R1, because the default behavior is E2, it shows it as 20 rather than 22. You can change this default behavior to type 1 external so that it shows the actual cost. And how do you do that? It is done via the redistribution. So configuration terminal, router OSPF1. Let me remove the redistribution. No redistribute, EIGRP subnet, no redistribute, right? Now let me again redistribute EIGRP 100 subnets. Now you can see metric type, right? Metric type, I will say it as metric type question mark 1. Okay. Now, what are the changes that we can see? Show IP protocols. We will see the changes in R1. Show IP route OSPF. Now we will see the first change that we can see is that instead of E2 route, it shows as E1 routes, and we can see the total cost as 22, right? And show IP route 4.4.4.1. We can see that it says the type is external 1 and the total metric is 22. This is basically the administrative distance value of OSPF, that is 110. So this is the difference between E1 and E2 routes. In E1 route, it calculates the total cost to reach the external network, including its internal cost via the ABR and the ASBR. But in E2, it does not show the actual cost, but it just shows the external cost that the ASBR shows. that is 20 here. So let me write that down here. In E2, the cost is not added by the individual routers. The cost is the cost is uh, the cost is 20, which is the uh, default E2 cost. But in E1, the cost of the individual routes are added to the external cost of 20. This is the difference between E1 and E2 routes. And we saw how R1 calculates its cost to reach the EIGRP network. And we saw how R2 in our diagram here, we saw how R2 being the ABR created the type 4 LSA. We saw how R3 created the type 5 LSA and told everyone in the OSPF network how to reach the EIGRP network. Okay, so this was our discussion for today about type 4 and type 5 LSA. I hope you liked it. Please do like, share, and subscribe to the channel. And please do let everyone know about this video if this was very informative for you. In the next video, we will be talking about LSA type 7, about different area types, that is stubby area, not so stubby area, totally stubby area, etc. So it will be an interesting one. So stay tuned till then and have a great day. Bye bye.